So in this video I'm going to show you how MYNTEYE camera S1030 camera uses IR to augment its depth calculation. So what you usually get is you get two stereo images, but each of these stereo images, for example, this is from the left camera, this is from the right camera and this left camera. So you get both the the grayscale image and your IR image. They get superimposed to generate this image, and from there you calculate your disparity and you get depth map like in here, and you get your point cloud in here. So this is my target object, a pen in here. Okay, so right now all settings are set to default. That is, the gain is set to 24, brightness 120, contrast 127, IR set to 160. And now I'm going to show you what happens if I turn off the light. So as you can see, even if the light is turned off and there is no grayscale image, you can still see image in this in here. That is because although the grayscale is gone, you still have the IR image captured both on the left and right camera, and from there you get your depth map in here and also get the point cloud. But what happens if I shine a very bright light? Okay, I have this torch in here. So look at the point cloud. It looks like as if someone is dropping a ball in there. And also the depth map on the left, you see that getting distorted because of the lighting. But someone may say that this is due to not controlling your exposure properly. So now I'm going to set the exposure down. So I just decreased the gain and brightness, but I kept the IR strength to 160 as before. So this is the manually controlled exposure image. As you can see that you cannot see anything in here. Before you could at least see the IR image captured in here, but now you don't see anything. That is because the exposure control. Now I'm going to shine the bright light. Now you can see. Okay, now let's turn on the point cloud. Cannot see anything in here. Same for the depth map. Before at least you could see the IR images captured in here. There is no light, so you don't have the grayscale image component. You at least had the IR images, but now you don't have that. But let's shine the light again, and now in the depth map in the left you can at least see the pen. On the point cloud you can at least see the pen as well, but this is not due to the IR. Reason number one is that you already can see in the images. If I turn off the light, there is no IR component in here. If there was IR component, you would have seen some patterns. But to definitively prove it, what I would do is that I would just turn off IR. So now I'm keeping my gain again just like previous experiment to 5, brightness to 12, contrast to default value 107, and the IR value was set to 160 previously. Now I'm going to set it to 0. So basically I'm turning off my IR. So this is the manually exposure controlled image, but here the IR is completely set to 0, so there is no IR projection coming out from the camera. But if I turn on my light just as before, I can see the image. This is only the grayscale component, because the IR component is set to 0. So now let's look at the depth. Just like before, you only get noise. In case of depth, you also see nothing, because in the grayscale plus IR image you get basically a completely dark image. But keep in mind that now in this left and right image there is no IR component, it's completely the grayscale image. Now if I turn on the light, now you can still see the pen in there. So this proves that IR has absolutely no role to play when it comes to finding this depth map in here. When I control the exposure, the IR component just completely got filtered out, and all the depth map that I'm getting in here is completely based on your grayscale. So in this sort of extreme lighting conditions, when we are going to decrease the exposure level, the IR component will be completely cut out, and it doesn't really work with extreme lighting anyway, as I previously showed with the example. Like whenever I turn on the light, there was a kind of like looked like that a ball is being dropped on the point cloud. So the IR from the point cloud the IR from the light already interferes with the IR from the camera, and moreover when you decrease the exposure, the IR component gets filtered out even more. So what you are left with is completely just grayscale image based depth estimation. So just for final, I'm just going to turn the light on and see what happens. So this is now the lights are turned on, but as the exposures are now controlled, you can still see very darkened image. Now I'm going to turn on the light again. As you can see, you don't see that ball dropping effect. I'm turning on the light on and off, but you see there is no interference with the IR, mainly because the IR is right now turned completely off. So the IR based image is not being distorted, because there is no IR projection from the camera. So that basically establishes that even if you have turned on your IR, it will be interfered continuously with the external light projection, and you basically will have to work with your grayscale images. And when you are going to do exposure control, even if you have an IR component, that will get further filtered out, so you cannot really work with IR in Mint. Thank you.